Not bad, not bad. I'm having a session at the moment, though. I'll call you back later. Yes, yes. Okay. Okay. All right, so we're going to start with our question. Here we go. All right. All right, so we're doing performance task. And again, welcome to Mathematics Resource Center. Happy to have you all joining us today as we go through a few questions. All right, so we're looking at performance task, and I'll just go ahead and read the first task. So this task challenge. So the task challenges to demonstrate understanding of area, surface area, and volume. All right. And for this task, you should be able to identify three-dimensional shapes or three-dimensional figures. So let me just ask anyone, can you tell me a three-dimensional figure? Ever heard the word three-dimensional before? 3D? Ever heard the term 3D before? Or looking at this solid that we have over here, can anyone tell me what this solid looks like? So this is a three-dimensional shape. Can anyone say what this shape is, what this solid is?
A cube.
A cube, all right, nice. So it's a cube. All right, so we're going to be using those properties, those skills that you have, the knowledge that you have about cube, cuboid, cylinder. Well, not necessarily using cylinder today, but using properties of three-dimensional. All right, and it says a student must understand the difference between area, surface area, and volume. Read diagrams of three-dimensional shapes and calculate using formulas, area, surface area, and volume. And these questions are taken from the grade 6 performance task book. They're exact questions from the book. All right, so if you have that book, it would be good for you to be using the book at the same time. Maybe you don't want to write in your book, but you can write on a piece of paper or something or in another book, but you can have that book with you. All right. So let's read the first part of the question. Anastasia baby brother, Benjamin, has a set of building blocks. Each block is 2 inches long, 2 inches wide, and 2 inches high. All right, so each block, 2 inches long, 2 inches wide, and 2 inches high. What solid is represented by the building blocks? So what solid is represented by the building block? If all the lengths are the same, what type of solid? And someone said it before, so you can go ahead and repeat it again. What solid is it?
A cube.
A cube. Well done, darling. All right, so that's the first part of our question. So it's a cube. All right, how do you know this? So the next part of the question say, how do you know this? How is it you know that that was a cube? Anyone can answer? How is it that we know that it was a cube? Each block It's 2 inches long, 2 inches wide, and 2 inches high. How is it we know that it was a cube? Anyone? Any of my bright?
Because of 12 blocks.
Does it have 12 blocks? All right, so good try, shake one, but think about it a little bit more. What do you know about a cube?
Oh, and
Yes, shake one?
um, I'm thinking about the answer later.
Okay, thinking about it. All right, so looking at it, how we know that it's a cube? Anyone else want to try? Ciara? Carissa? Want to try? All right, so I'm going to go ahead and talk, give you the solution to this, how we know it's a cube. So when we look at it, it's 2
Excuse
inches
me.
long. Yes, Carissa, go ahead, darling.
These maps are older than me, Miss.
They're older than you. All right. So how we know it's a cube, right? It is because all the sides are the same. So the length, so it's 2 inches long, 2 inches wide, and 2 inches high. So because all the lengths are the same, then we know that we're looking at a cube. Understand how we know that it's a cube now?
Yes, and Felica, and have one more thing.
Mm-hmm.
One reason is because it is because two can grant like 12 to the even number and 12 the even number.
2 is an even number and 12 is an even number. Well, we cannot look no, so I won't take that response as the reason why it is a cube, right? Even though both of the numbers that you're giving are even number, the main reason why it is a cube is because all the sides are the same. All right.
Okay.
So the height is 2, the width is 2, and the length is 2. So if I give you another figure and I say one length is 3 inches, say for instance, I say one length is 3 inches, the other is 4 inches, so 3 inches long, 4 inches wide, and 6 inches high. Would this be a cube?
No.
No, miss.
No, it wouldn't be. All right, well done. And why wouldn't it be a cube?
Because all of the sides are not the same.
All of the sides are not the same. All right. And another thing that you can also think of is that the cube is made up of squares, right? And with a square, all the sides are the same. All right. So we have finished the first question. Let's go to the second question now. And this one says, how many faces does each block have? So we're looking at a cube. And I don't have a cube to show you now, but we're looking at a cube. And a cube, if I can find, no, I don't have a cube. All right, so we're looking at a cube. And, all right, so shake one, say 12. All right, think about it again. So the face is the flat part. So just looking at this, the face would be the flat part. I don't know
Miss,
if you're
a
seeing
cube
this.
has 6 faces.
A cube has 6 faces. All right, so it would be the flat part. So this is not a cube, but we could use this just for example. So we have one face here, one face there. So that's 2, 3, 4, 5, and 6. So as Saraya, I don't know if I pronounced the name correctly, says cube has 6 faces. So when we count all the faces, think of a dice and you look at all the faces, it has 6 faces, all right? So 6 faces. All right, Shaquan, read the next question for me.
What surface area is covered by one of Benjamin block? Show how you figure this out.
All right. So when we talk about Benjamin block now, so I'm going back to this jar just in hope you're seeing it. So when we talk about Benjamin block now, Benjamin block has 6 faces, right? And say this is one of the face, right? When we talk about surface area, we're finding the area of all the faces. So this is one face. So we're going to find the area of this face. We're going to find the area of this face. We're going to find the area of this face, area of this face, area here, and area there, and add them all together. So that's how we're going to find our surface area. So looking at Benjamin block. So Benjamin block. What is the length of each of his face, of the one of his face? So remember it's a cube, right? So we're looking at a cube. What did they say that the length is? Oops.
2 inches.
2 inches. And what's the width?
2 inches.
2 inches. Good. So come over here now and we'll put on our 2 inches. Good. And up here is our 2 inches. And because Benjamin block is a cube, then we know that all the 6 faces are going to have the same length and
Width.
width. All right. So all the sides would be the same. So that's 2. That part is 2. That part is 2. That part is 2. So as we go around, all the lengths would be the same. The length, the width, and the height would always be the same. So let's calculate the area of one of these faces. How do I calculate the area of a square?
Length and width.
Length times width. All right. And sometimes we can say, anyone else have another way of saying it? Well done, Shanive. Anyone have another way of saying it apart from length times width? Anyone ever heard length times length? Or side times side? No? Yes? All right, so we could say length times width, right? Or we could say side times side, or we could say length times length, because all of them are the same. All right, so we're going to go ahead and find our area, and it's length times width, so it is 2 times, what's the width?
2 inches.
2 inches, all right. So we say 2 times 2, and what is 2 times 2?
4
4.
inches.
4, good. And am I finished here? Do I write anything after I write the 4?
Yes, miss.
What do I write?
Inches.
Just inches?
Your unit.
Yes, unit. So the unit is inches. But anything comes after writing the inches? Since we're finding area?
Square.
Square. Well done. All right. So we find the area of one of the face, right? And that is 4 inches square. So how many face do we have? How many faces does the cube have?
4 faces.
Check again. So remember we answered it up here. How many faces?
6 faces.
6 faces.
It has, good.
Oh,
It
sorry,
has 6
6 faces.
faces. Good.
Actually, I said 4, sorry.
All right, that's okay, Shaquan. So it has 6 faces. So given that one face is 4 inches, 4 inches squared, how would I find the total for the 6 faces?
Miss, you can add 4 6 times, or you can multiply the 4 by the 6.
All right, well done. So we can add 4 6 times, or we can multiply the 6, the 4 by the 6. Let's see which one would be easier. Which one do you think is easier?
By 6.
4 by 6. So we could have added 4 6 times, and adding 4 6 times, what would be your answer? 4 plus 4?
20, answer would be 25.
Check again. Almost there. Almost there.
24.
24. All right, so it would be 24 inches squared. All right, or the shorter method is to multiply that 4 inches by 6, which also give us 24. All right. All right. So our answer is 24 inches squared. All right. How is that so far? Is it hard,
No.
Kavis? No?
No, miss.
No? How do you find that so far, Kavis? Right? All right.
A
So we're
little
going to
difficult and a little easy.
a little difficult and a little easy. All right, Carissa. All right, good. All right, so we have found the surface area, so we're going to go to the next question now. All right, this question, Carissa, go ahead and read this question for me, darling.
After playing with his blocks,
Miss, can I read?
Yes, 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 go ahead, darling, go ahead.
After playing with his blocks, Benjamin
Mm-hmm.
wants to fill the bag with the blocks. However, he can't find the bag he took them from. Anastasia gave him a box with the following dimensions: length 8 centimeters, width 2 centimeters, and height 6 centimeters.
Mm-hmm.
What is the volume of the box? Dash cube inches. Show your working.
All right. So after playing with his blocks, so Benjamin is your little baby brother, and he was there playing with those blocks. And after playing with them, he can't find the bag that he had them in. So you, as the bigger sister or the bigger brother, say, okay, let me give you a box. All right, so it would be bigger sister since we're talking about Anastasia. So Anastasia gave him a box. And let's look at the dimensions of the box now. The length of the box, 8 centimeter. The width of the box, 2 centimeters. And the height, 6 centimeters. Now, what is the question asking you to do? What are you required to do? So that's the first thing I want you to point out.
Can I answer again?
What are you asked to do? Yes, Shekwan?
You would multiply.
Okay, before you talk about what steps you're going to take, what is the question asking you for? So before you tell
Okay.
me the steps that you're going to take, tell me what the question is asking you to find.
Oh, asking you to find the volume.
The volume. Well done. So asking you to find the volume of the box. All right. And when we look at this box, so which solid does it look like? So we talk about solid, we have cylinder, we have cone, we have cube, we have cuboid. So I mentioned 4 so far. We have pyramids too. So I mentioned 5. Out of those 5, which one of those is this box? Would that box
Uh,
represent?
Cube.
Cube. So someone says a cube. So let's think about it. Let's
Cuboid.
go back to our previous question to see if that is, let's look at it. So you remember when we talk about the cube over here, this one being a cube? What was special about this cube? How did we know that it was a cube?
Because it has all of the sides are the same.
All of the sides are the same. Nice. So let's come back to this question that we're looking at now. Would you say that this is a cube?
No means I changed my answer.
Okay. And what
would
you
say
change your
no.
answer to now?
I think it's a cuboid.
Okay, it's a cuboid. Good.
I
So it
said
is,
that, but you didn't hear me.
oh, you said that, Shake One? Okay, my apologies, Shake One. All right, so it's a cuboid. All right. Anyone have another name for a cuboid? Any other name we call a cuboid?
A rectangular prism.
A rectangular prism. All right, so it's either a cuboid or a rectangular prism. Nice. All right, so we can call it a cuboid, or sometimes we refer to it as a rectangular prism. So let's write down those two information in our book. So we have cuboid, or we can refer to it as a rectangular prism. All right. Can someone tell me how I'd know that this is a cuboid? Remind me of what I used to know that this is a cuboid. This box is a cuboid. So I've heard
Can
from
I answer?
Sahari, and I've heard from Shaquan.
Oh, sorry.
All right, Kavis, go ahead, Kavis. Go ahead, darling. Try again, Kavis. Try unmuting your mic again. I wasn't hearing you the first time. So try again, darling. All right. So I've heard from Sahari. I've heard from Shekwan. So can someone else tell me how we know that this box is a cuboid?
It has a rectangular shape.
It has a rectangular shape. All right, so that's one way to say yes, looking at it. Yes, it has a rectangular shape. Okay, yes. I'll go with that. Any other thing? So,
I
so
would
I've heard,
say
yes, go ahead.
all because the sizes are different.
All because the sides are different. And how do you know the sides are different, Carissa? Tell me the difference in sides, Carissa.
Because one number is 8, one number is 2,
Good.
and one number is 6.
Awesome. All right. So thank you, Carissa. Thank you, Shanive. Thank you, Sahari and Shaquan. Well done. All right. So we're looking at it and we know it's a cuboid because the sides are different. All right. However, it could be that one side could have been 2 centimeters and another side could have been 2 centimeters and the height 6 centimeters. And it would still be a cuboid. All right. Would it be a cube? Because all the sides aren't equal. It would still be a cuboid. All right. So now we're going to go ahead and we're going to find the volume. How do we find the volume of a cuboid? So the letter V represents volume. How do we find the volume of a cuboid?
Repeat what that said, Angelica.
What is the formula to find the volume of a cuboid? I want you to go ahead now and search through that brain. You remember Miss teaching you or start teaching you all of those formulas? Remember seeing those formulas before? Go ahead and search through and find that formula for finding volume of a cuboid.
Length time with time height.
Length times width times height. Well done, Shaquan. Length times width times height. All right. So I'm going to ask Carissa now to give me the length. Carissa, what is the length? Thank you, Shaquan. Well done. What is the length? Go ahead, darling.
8 centimeter times 2 centimeter times 6 centimeters.
Right. Thank you, Shanive. Thank you, Carissa. So it's 8 centimeters times 2 centimeters. Let me just be as Shanive said, 8 centimeters times 2 centimeters times 6 centimeters. So I put in my units. All right, well done, Shanive. All right. So who can go ahead and tell me the final answer for that? 8 times 2 times 6.
96 centimeters
All right. Thank you,
square.
Sahari. So 96 centimeters. Is it centimeters?
Yes, miss.
Is it just centimeters?
No, 9 centimeters square.
Is it centimeters square? Is it? I am doing volume. When I do volume, is it centimeters square or is it unit square? Isn't that for area?
Yes, miss.
Okay, so what is it for volume?
Unit square.
No, that's for area. Unit square is for area. So whatever the unit is, if it's centimeters, so we'd say centimeter square. If it's meter, we'd say meter square. So that is for area. What would it be for volume? Yes, shake one.
You have 9 centimeters, not 96 centimeters.
Oh, thank you. Thank you so much, shake one. Thank you, darling. So it's 96.
Miss, it will just be 96 centimeters.
Square.
Not square.
No,
So let's
miss,
look at
it
the
will
word here.
96.
Cubic.
Oh,
What does cubic stands? What number represents cubic?
3.
So if go again.
3.
3. All right. So it is 96 cubic centimeters. All right. So 2 is for square and 3 is for cubic or cube. And when we're doing volume, it is cubic. All right, it's cube. So it's 96 cubic centimeters. If it was square, if it was area, then it would have been square. So for volume, it is cube. All right, I give you about a minute to take your solutions off, and then we go to the next question. And well done to all the persons who have been participating so far. You're doing really, really good. All right, so take your solutions off, and then we continue to the next question. Right, so we're going to the next question now. All right. So the next question, read for me, Shanive.
How many of Benjamin's 100 blocks can in hold?
All
Show
right.
how you figure out this.
All right. So thank you, Shanive. Beautiful reading. All right. So how many of Benjamin blocks can it hold? All right. So there goes our box. And we want to figure out how many of these blocks can hold into that box. All right. So how many of those blocks? And we found the volume of one of those blocks to be 8 centimeters cubed. So let's just work that out since that was worked out just now. So let's work it out. So going back to our question previously, one of Benjamin's block is 2 inches long, 2 inches wide, and 2 inches high. And if we were supposed to find the volume for Benjamin block, it would have been the 2 inches times the 2 inches times the 2 inches, which gives us 2 times 2.
6 centimeters
Are you
cubic.
Eight,
sure?
8 centimeters.
8 centimeters. So check it now. So it's 2 times 2, 4. 4 times 2, which gives us 8 cubic centimeters. All right. Yes. So that's how we got our 8 here for the box. So one of those boxes, the volume of one of those blocks is 2 times 2 times 2, which gives us 8 cubic centimeters. All right. How many of those can we fit into that box? All right. How many of these little blocks can I fit into that box? Can anyone tell me what you do to figure that out?
Can I try?
Yes, shake one. You can go ahead, try.
8 centimeters. Eight.
8 of them.
Yes, I'm spelling.
All right. So shake one say would fit 8 of them. Why did you say 8, shake one? Did you randomly choose that number? Why 8?
Because
Mm-hmm.
reason why I choose 8 is because two it is 2 centimeters. Length is 2 centimeters, which is
Mm-hmm.
2 centimeters, and the height is 2 centimeters.
Mm-hmm.
And if you multiply 2 times 2 times 2, you get 8 centimeters. So that's why I said 8 of them can hold in the box.
Okay, but that calculation that you did was for the volume of the little box. So let's think about it now. What is the volume of the big box? So the big box that Benjamin is going to place everything in. What is the volume of that big box? Anyone remember the volume of the big box that we calculated earlier?
96.
96. Good. All right. So it's 96 cubic centimeters. So how many of these 8 cubic centimeter box, of how many of those can I fit into this big box? So it cannot pass 96. It has to be less than 96. How many would it take to fill that box up? Each is 8. So if each value 8, so we can forget about using the term cubic centimeters for now. So if each value 8, how many can I fit into the box before reaching 96? Or I can put it in another way. If I give you $96 to spend and you're buying candies costing $8 each, how many of those $8 candies can you buy before your money is all gone?
12.
12. How did you get 12, Sahari?
I divided 8 by 96.
Okay, so it's the other way around. You divided 96 by 8. All right, well done. Yes,
I
Kaviz?
did the same thing.
All right, well done, Shaquan. Yes, Kaviz? All right, so to figure out how many we can hold, we divide 96. So let's just leave the units off for now. So we divide 96 by 8. And 96 by 8 gives us 12.
Well,
All right, so 12 blocks we can place into that box. All right, so 12 of those would hold. All right, And if it's a case where you can't figure out that you divide, you can always use trial and error. It will take you a bit longer, but you'll get the answer. So you could keep adding 8 until you reach 96. So you could keep adding 8 blocks until you reach 96. So just in case you don't know, you didn't know how to divide, you weren't aware that you could divide 96 by 8. We could say, okay, 2 blocks is 16, still not 96 yet. 3 blocks is 24, still not 96 yet. And you keep adding until you reach 96 or closest to 96. All right. So here we'd have 12 blocks. All right. I give persons a minute, give you all a minute to write this off. All right. Finish writing check one or not yet?
Not yet.
All right. So I give you a minute to write. All right. And if I'm going to move on and you're not finished writing, you tell me so I can stop. All right. Finish writing, Shanive.
Miss, I don't really write it. It's my mommy phone I'm using, so I just screenshot.
Okay. All right, Shanive. Finish writing, Carissa. Finish writing, Sahari.
Yes, miss.
Okay. Finish writing now, Shake One.
Almost.
All right. Okay. Right. So we're at the second task. And you would like
Finish.
to read for me? Would you like to read for me, Shake One?
No one feel so
Can I go,
Will-
miss?
Yes, darling, go ahead for me. Thank you.
The task challenges a student
All right, so I'm going to go ahead and read. So the task
Actually,
challenges.
I will read.
All right, go ahead, check one.
The task challenges a student to demonstrate understanding of concept of measurement. A
Mm-hmm.
student must understand area and perimeter of rectangles and difference between the two measurements. A student must understand that when area challenges, the perimeter can remain the same. The students will also determine lines of symmetry in an area. The grade for students have a play area. These are the
These are its measurements.
measurements.
Mm-hmm.
Measurements. Number one, what is the area of a play area? The square yard. Show how you figured this out.
All right. Thank you, Shaquan. Wonderful reading. All right. Thank you, Shaquan. All right. So we must know area, know how to find area, know how to find perimeter, and we're also being challenged to use we also a student must understand that when area changes, the perimeter remain the same. All right, so that's three things that will be tested on. One, oops, okay. Oh, sorry, just a sec. It's in here. All right, good. So one will be tested on perimeter, will be tested on area of rectangles, right? And we also need to know that when area changes, the perimeter remain the same. So the area can change, but the perimeter is going to remain the same. All right. So throughout this task, those are the things that you'll be tested for. All right. So the first question says, what is the area of the play area? And the picture doesn't show it as I would want it to show. However, it's a rectangle. All right. So it is a rectangle. This side here is 20 yards. And this side here is 30 yards. And what is our area?
600
Denise,
yards square.
go again, Sahari.
Miss, it's 600 yards square.
Okay, so 600 yards square. So that's the answer. Now, can you tell me how you got your answer? So show how you figure this out.
Miss, you multiplied 30, you multiplied 30 by 20,
Mm-hmm.
and then you're going to get your answer.
All right. So for us to find the area of a rectangle, as Sahari says, well done, Sahari, it is length times width, which is 30 times 20, and that gives us 600 yards square. All right. So for this question, all I want you to do is to draw in your book a representation of the diagram as I've drawn over here. So I want you to draw that in your book, the rectangle showing the 30 yards by 20 yards, and then write down your question, which states, what is the area of the play area? And show your solution. All right, so I don't want you to be writing the entire question. So I want you to write that part of the question, your solution, and the diagram. All right, so draw your diagram. Please use a ruler so your work will look neat. All right, don't freehand, use a ruler or use a straight edge. So draw your rectangle, 20 yards, 20 yards by 30 yards. All right. Shanive,
Yes, ma'am.
what is the formula for finding the area of a rectangle?
10 times width.
Length times width. Well done, Shanive. All right. So while you're working, I'm still giving you questions in between. Kaviz, Kaviz, right? Chiara,
Yes, ma'am.
okay. So I'm going to give you a quick little question. If the length of this rectangle was 40 and the width was 10, what would have been the area? If the length was 40, if the length was 40 and the width was 10, what would have been the area? So I'm giving you time to write off what you're supposed to write and just quizzing you in the meantime. All right? It would have been 50. All right, I want you to recheck that for me. So remember we're doing length times width. So it'll be 40 times 10. So multiply, to find the area, we'd need to multiply 40 by 10. 40 times 10. All right, yes, it would be?
400.
Awesome, 400. All right, so there goes our extra question. All right, so it'll be 400 yards square. All right, finish writing now, Sahari. Finish writing, Kaviz. Carissa, Shaquan, finish writing.
Finish.
All right, good. Carissa, finish writing, darling.
I screenshot it, miss.
Okay, all right, and Shaquan is finished. All right, so we're gonna go to our next question. All right. Carissa, read this question for me, darling.
Krista. Pasta. Mother. Mother.
Can I read Angelica?
No, not yet, Shaquan. Just let's see if Carissa is going to read. Carissa, and then if not, we pass it on to you. Okay, Shaquan?
Okay, Angelica.
All right, darling. Carissa,
Yes, ma'am.
read this question for me, darling.
The student would like the fence to be put around the area to stop balls going too far. What will the total length of the fence be?
All right. Thank you, Carissa.
That's yard.
Mm-hmm.
So how you figure this out?
Thank you, Carissa. Beautiful reading. Thank you. Well done. All right. So the students want to put a fence around the yard, all right, around the area, their play area. So they want to put a fence right around the play area. What will the total length of the fence be? So when you think about going around, fencing around the play area, which measurement word comes to mind? Anyone can answer?
Perimeter.
Perimeter. Well done, Shaquan. All right. So now that we're thinking about perimeter, let me just redraw the diagram. See if we use another color. All right, so this is freehand. Sorry, not the best. Okay, so here is 30 yards, and here is 20 yards. If I'm going to go fence this area, how much fencing would I need? What's the total length of fencing would I need?
100.
100. So anyone agree with that answer? So Sahari says 100. Anyone agree with 100? Carissa, do you agree with 100?
Yes, miss.
Okay,
I
so
agree.
Carissa agrees, Shaquan agree. Okay, all right. So since you agree with Sahari, can you explain to me? So you say 100 yards. Can you show me how you got your answer?
Me, miss?
Yes, you can go ahead, Sahari.
Miss, I got it by adding all of the sides.
Mm-hmm.
30 plus 30, 20
Mm-hmm.
20, and I got 100.
But I only see 30 here and 20 there. So that would just be 50. So how you got the other sides? What did you do to get the value of the other sides?
Miss,
True, the sides are equal.
All right, so Shanice said that the sides are equal. All right, yes, so Sahari, were you adding something?
yes, miss, you
Mm,
would do like that with area, but when you're doing the perimeter, if you had 30 at, if you have 30 at the top,
mm-hmm,
have 30 at the bottom, and if you had 20 at the side, you will
mm-hmm.
have 20 at the other side.
All right, so well done, Sahari, and well done, Shanice. So Shanice said the sides are equal, so the opposite sides are equal. So it end up getting 20 and another 30, and that gives us 100. Well done, my bright students. All right. So that's 100 yards. So need the total length of fence needed would be 100 yards. All right, let's go to the next question. Okay, Shaquan, you can go ahead and read this one for me, darling.
Shade, shade one area. Shade one area, then determine. Shade. My phone is malfunctioning. Go and
Okay,
stay one place.
all right. So ask someone else to read then, Shaquan. Ciara, would you like to
Okay.
read? All right,
Shade
read for me, darling.
one area, then determine.
Miss, can I read?
All right, just a sec. Sierra is about to read, but Shake One. All right. All right, go ahead and read for me, Sierra. Sierra.
Shade one area then determine parameters of the shaded area.
All right, so that's the last part. What about the first part? Read the first part for me, Chiara. The girls say.
The girls say that the boys take up too much space with their
Mm-hmm.
ball game.
Mm-hmm.
They want the area to be split into two equal parts. Draw two possible ways of dividing the area into equal parts.
All right. So thank you, Chiara. Wonderful reading. All right, so let me just draw the diagram again. All right, so that is the the field, right? The play area. So now I want you to draw two possible ways of dividing this play area into two halves. So I want you to go ahead and draw that in your book. And after you finish drawing it in your book, then I'm going to show you how I would draw it myself. All right? Okay.
Miss, can I try something?
Oh, sure. Go ahead, darling. Wonderful. Of course. Go ahead.
It says the half. So I would say, like, if you add 30 and 20, you'd get 50.
Mm-hmm.
So you could cut the ball game in half, and
Mm-hmm.
each side would be 50-50, because if you add up the 30 and the 20, you'll get 50 over the boy side and 50 over the girl side.
So each side would
Equal to 50.
equal to 50. All right. Would you like to show me how you would you can are you able to draw on screen?
No, miss.
No, we don't have that option. All right. All right. I would rather for you to show me exactly. So 50 and 50. I understand what you're saying, but don't totally agree with the measurements. All right. So
Yes.
remember now we're splitting this into two halves, right? So as we split this into two halves, we're thinking about different ways that we can split it. All right. So if we split it, it's possible that one side would be 15 at the top. So we split the 13 into two. So one would be 15 and the other would be 15. And then here would be 20 just the same, and over here would be 20. Is anyone able to draw on screen to show me your example, what you would have done?
I can try and later.
All right, go ahead, shake one, and then I show you what I would have done. All right. You can make the markings on the diagram here, shake one. So
Oh,
you could,
sorry.
yeah, just split this one, right, instead of drawing again.
I can't do it, Aunt Falika. My phone is my mom phone is malfunctioning.
All right, that's okay. All right, so I'm going to show you how I would have done it. All right, so I hope everyone have written down how they would have drawn theirs, and then I'm showing you how I would have done mine. So I could have split it into two, like going across here. So the boys would be at that part and the girls would be at the bottom. All right, and that would have been 10 yards. That would have been 10 yards and 20 yards. So we could split it like that. Or another way we could have split it is instead of going across like that, we could have come down the middle, right? Exactly down the middle, right? So the boys would have gotten the top and the girls gotten the bottom, all right? So that would have been, well, here would have been 20 yards, not 10, and there would have been 15 yards, and there would have been 15 yards. So we split it. It's the same playground, right? Same playground, but we're splitting it. So if the length was, if we split it this way, if we split it along the width, then one team is going to get 10 yards and the other team is going to get 10 yards. If we split it along the length, then the girls are gonna get 15 yards, the boys is gonna get 15 yards. However, our width, original width would have remained the same 20 yards. All right, so that's one way to split it. All right, the next part of the question says shade one area, then determine the perimeter of these shaded areas. So we're at shade one area. So which one would you like us to do? Would you like us to do this one or would you like us to do the second one?
The top one.
So do you want us to do the first one here? So this is number one and this is number two. So they said we're supposed to shade one area. So which of them would you like us to shade that one area from? Would you like us to shade the one area from the first diagram or from the second diagram?
First diagram.
All right, so we're going to do it from the first diagram. So it says shade one area. So we're shading one area. So this is one of the play area so this will be the girls' play area. Since we use the color yellow. So this will be the girls' play area. So we shade this play area. And the girls going to be separating their play area from the boys. So they're going to go ahead and fence around their play area, separate from the boys' play area. If we're supposed to fence this around, what would be the perimeter for this area? This is shade one area, shade that area. And I hope everyone is doing this in their book. So we shade our one area. And the next is determine the perimeter. So I'm going to give you a minute to determine the perimeter of that part that I've shaded. And then after the minute, I'll take your answers. Right? So you're finding the perimeter of that shaded area.
Auntie Falika, the length of the The play area would be just trying length of the play area would be 20, and the width of the play area would be let's check this out. That would be 225.
Okay, so Shake One says his answer is 225. So 225 for Shake One. The 225 yards, is that what you're saying, Shake One?
Yes, Angelica. That
All
that was
right.
that.
All right, so that's Shake One's answer. And anyone else waiting for your answer, you can go ahead and unmute, tell me what your answer is, and then we discuss to see which answer is indeed correct. Taneve, what is your answer? Sahari? So we're finding the perimeter of that shaded one. All right, perimeter of that shaded one. How do we do that? Carissa, Kavis, yes, Shanive? Got your answer now, darling?
Is it 60? Miss,
Okay,
is
so
it 60?
all right, so Shanive
Miss,
says
is it
it's
60?
60 yards, so that's Shanive's answer. All right, so that's Shanive. That's right, SEN. And that's Shake One, FAQ. All right, anyone else? So we have 2 answers so far. Sahari, perimeter.
Yes, Miss, I'm still working it out.
Okay, all right. All right, Ciara says it's 60. All right, so given that I have 3 answers now, so Ciara says it's
I got mine
60. What did you get as yours?
60.
All right, so I have 360 and 225. All right, what do you think, Shaquan? Do you think that you're the one that's correct and everyone else incorrect? Shaquan,
I'm keeping with my 225.
you're keeping your 225. Well, I
Yeah.
must applaud you, Shaquan, for your confidence. I must applaud you for your confidence. So let's see, Shaquan, if that's correct. So we're finding the perimeter of one of those shapes, of one of those of play area. So let's look at it now. So here is 10. So here is 10 and here is 20. So that's 10 yards and that's 20. So if that's 10 and that's 20, then up here is 20 and over here is 10. So let's add them up now, Shake One. 10 plus 20. Shake One.
30, Angelica.
Plus 10.
40.
Plus 20.
60.
So what's the perimeter?
Oh boy, 60.
60. Don't worry. At least you have that confidence, all right, to hold on to, all right? So it is 60. All right. Well done. Good try, Shaquan. Well done, Shanive. Well done, Ciara. Well done, Sahari. All right. So that would be it for our session today, right? We have another, there are other parts to this question. We'll do that again next week. So thank you for joining today. Go ahead and take off the solutions if you haven't as yet. And it was a pleasure being here with you at Mathematics Resource Center, and see you again next week. The video is live on YouTube, so you can go back and watch the video on YouTube at Mathematics Resource Center, and you can also share with your friends and have them join next week. All right, so until next week, bye bye.